Good day, senior high school students, and welcome back. I am your online math teacher, Ma'am Karim. I am so glad that you are here to join us in the next lesson for statistics and probability. Our topic today is all about the normal distribution. For the objectives, number one, illustrate a normal random variable and its characteristics. Number two, construct a normal curve. Number three, identify regions under the normal curve corresponding to different standard normal values. Number four, convert a normal random variable to a standard normal variable and vice versa. And last, compute probabilities and percentiles using the standard normal table. In our previous discussion, we have talked about on how to construct a probability histogram given a distribution with random variable and its probability. Let's have this example. If a researcher selects a random sample of 100 adult male, measures their heights, and constructs a histogram, the researcher gets the graph similar to the one presented. In the horizontal line, you can see here the height of 100 adult males as the random variable, and the height of each bar in the graph is the corresponding probability of the random variable. Kung mapapansin nyo dito sa graph, yung pinakamataas na bar ay makikita sa gitna, which is 16. If we are going to consider the measure of the heights of all adults in the Philippines, which is in million, the histogram would come close to what is called a normal distribution. In this graph, the highest part is at the center. When we say normal distribution, it can be used to describe at least approximately any random variable that tends to cluster around the mean. So if the probability histogram of a random variable and its probability is like this, that data or that probability histogram of yours is also called as the normal distribution. Let us clearly define normal distribution or normal probability distribution is a type of a continuous probability distribution that describes data that clusters around the mean. The graph of the associated probability density function is bell-shaped. Kaya kung mapapansin mo sa previous slide, yung shape ng normal curve is like a bell with a peak at the mean that can be found at the center. In other references, normal distribution is also called Gaussian distribution because it was first discovered by Carl Friedrich Gauss. There are 7 properties of a normal curve. Number 1. The curve of the distribution is bell-shaped. The shape of a normal distribution is like a bell. Number 2. The mean, median, and mode are all equal. They can be found at the center of the graph. So this center is considered as the mean, median, and mode. Number 3. The curve is symmetric around the mean. From the mean to the left side of the curve and from the mean to the right side of the curve have the same area. In short, the normal curve has symmetrical sides. Number 4. The curve is asymptotic to the horizontal axis. The curve has asymptotic tails. When we say asymptotic, it or the curve always approach the axis or the baseline but never touch it. Number 5. The width of the curve is determined by the standard deviation of the distribution. If we are going to identify the area or the probability of the distribution, we should consider the label on the baseline, which is, take note, at the center, we have the mean. You have learned this one in our previous discussion that this symbol is the symbol for the mean. Going to the right side, we have the mean plus the standard deviation. Here we have the mean plus twice the standard deviation. And here we have the mean plus thrice of the standard deviation. From the mean or from the center to the left side of the curve, we have the mean minus the standard deviation. Here we have the mean minus twice of the standard deviation. And here we have the mean minus thrice of the standard deviation. This justifies that the width or the spreadness of the curve is determined by the standard deviation. Number 6. The total area or the probability under the normal curve or under the normal distribution is equal to 100%, or we have 50% from the mean to the left side, that is 50%, or the probability is 0.50 or 0.5. And from the mean to the right side is also 50% or 0.50 or 0.5. If we are going to add the half of the curve and the other half of it, that is equal to 0.5 plus 0.5 is 1 or 100%. Number 7. Every normal curve corresponds to the empirical rule or the 68, 95, 99.7% rule. Ang ibig sabihin nito, given the mean at the center and the width of the curve is determined by the standard deviation, from the mean minus the standard deviation to mean plus the standard deviation, or the pink area, is only 68.27%. Take note of this because we're going to use this in identifying the percentile using the normal distribution. The pink area from the mean minus the standard deviation up to the mean plus the standard deviation, that is 68.27%. From the mean minus 2 standard deviation up to mean plus 2 standard deviation, that is from here up to here, that is all in all, the area is 95.45%. And from mean minus 3 standard deviation up to the other side, which is the mean plus 3 standard deviation, that is all in all 99.73%. So ito yung tinatawag na empirical rule. To determine the area or the probability of a region under the normal curve, we have to take note of the standard normal distribution. When we say standard normal distribution, it is denoted by Z. It is a normal distribution having a mean of 0, which can be found at the center, and a standard deviation of 1. Z-table is a tool to use to identify the probability or area. In this slide, we can find the standard normal table for Z. To identify the area from the mean up to any Z-score, take note that the first column is the first two digits of Z, that is from 0.0 up to 3.4, and in the first row, that is the last digit of Z, which is in the hundredth place. That is from 0.00 up to 0.09. To find the area of the mean to the Z-score, you can find it in the table. That is from 0.0000, we have here 4 decimal places, up to 0.4998. Example, given the area or find the area from the mean up to 1.35. What are the first two digits of the Z-score? That is 1.3. How about the last digit of 1.35? Take a look at the first row. That is 0.05. Get the intersection from the first column, and from the first row, we have here the area 0.4115. Again, this area or this probability is the probability from the mean up to 1.35 as the Z-score. Another example, what is the area or the probability from the mean to Z is equal to 1.90? The first question, what are the first two digits of the given Z-score, which is 1.90? That is 1.9 from the first column. In the first row, we have the last digit, which is the last digit of 1.9 or 1.90, which is 0.00. Get the intersection, the area from the mean to the Z-score 1.90 is 0.4718.